Okay. Well, welcome back. I hope you had a scrumptious lunch and something decent to drink. So we're going to launch this afternoon session on DevSecOps. You know, in the last session, I talked about DevOps and trying to find measures for measuring the efficiency, the quality, the architectural issues, the productivity of those environments. And the next step beyond that is to make sure that what you're producing is secure software components and a secure architecture. And so Nicolas Chaillan, who is the Chief Software Officer of the U.S. Air Force, and Dr. Ron Ross, who is the leader at NIST of a lot of the cybersecurity framework, National Cybersecurity Framework activity, are going to talk about their effort to create a major DevSecOps initiative inside the federal government, especially in the Department of Defense. So let me turn it over to you. I guess, Nicolas, you'll talk first.
Yeah, and Nick, I have your slides here as well. Hopefully everyone can see that shared on the screen.
No, absolutely, we can see it. And sorry, I was muted, so I couldn't talk. Here we go. Now I can talk. You can hear me, right?
Yes.
Well, I'll go quickly. I know we want to have a discussion as well. And are we taking questions as well, or are we just talking?
We'll take questions at the end of the session.
All right, sounds good. So I wanted to share a little bit quickly what we've been going through in the last, 2 years now, between the Air Force and the DoD. I'm Nicolas, I'm the Chief Software Officer for the Air Force. I'm also the co-lead of the DevSecOps initiative, and that's in partnership with DoD CIO. If we go to the next slide. And of course, timeliness is one of the key benefits of moving to DevSecOps, and we need to rapidly adapt to challenges. Next slide. And we'll go quickly on the next few slides if you can just next every time I talk. We need to work as a team, a pretty large team, as you can see, with quite a few different technologies between jets and bombers and space and nuclear systems. We need to bring it with us, and even to space, which is obviously easy. And then, of course, with quite a few sensors, and that complexify the entire system. We need to be modular, we need to be agile, we need to be able to swap things around, we need to be doing that with all these people's help. And that's across countries in multiple different programs across the department. Next slide, please. So the DevSecOps initiative is a joint team between DoD CIO and DISA, the Air Force, and ANS. And we created two enterprise teams. One is Cloud One, and the second one is Platform One. Cloud One is a cloud team, access to Amazon and Azure, and Platform One is the managed DevSecOps team that can bring a DevSecOps pipeline on any environment, whether it's a cloud, a jet, a bomber, on-premise, at the edge, on classified clouds, and bring that timeliness and modularity and enabling reuse across teams. The first piece for us was not to get locked into a specific product, so we picked Kubernetes to orchestrate and coordinate the work. And Kubernetes is part of the Cloud Native Computing Foundation, and we use containers as reusable Lego blocks that you can swap around and bring that flexibility when it comes to using different options. That's why we created Iron Bank, which is a DoD centralized artifact repo of containers. That's where we centrally harden and accredit containers. Everything we do is open source, so anyone can go and check it out, which is pretty amazing because we have the entire code base, all the automation code and infrastructure as code and Terraform, everything is on the source code repo. And of course, we wanted to bring also the zero trust cybersecurity principles. We're in 2020 after all, and we are using behavior detection and zero trust down to the container level to be able to whitelist access for container A to talk to container B, and using strong identity, the concept of a sidecar container security stack. We'll talk about that a little bit. Of course, we're also partnering with NIST and Ron Ross on the line here to be able to try to bring this concept that we created about 2 years ago of a continuous authority to operate, a continuous ATO, and we're defining the gates and trying to scale this at a broader .gov level with NIST. The concept behind the CATO is to accredit the factory and the process and the gates within the factory, and authorize teams to use the factory. And then what comes out of the factory is accredited, meaning the software produced multiple times a day as needed is coming out of the factory as already passing the requirements, and automating the RMF process by using layers. We'll talk about that as well. We have to train a few people, 100,000 people this year. So we're bringing self-learning capability with unbiased content from Linux Foundation, Cloud Native Computing Foundation, and O'Reilly the books. So that's also something pretty exciting. And then next slide, we are kind of bringing this stack as an open source model, and we are sharing all of the documentation, videos, training content. Everything is on the software.me website /DSA/documents. You can go there and find our training content, all of the Cloud One link, Repo One, which is the source code repo side of the house, Iron Bank, the sign containers, everything is on those links. So feel free to check it out. Next slide, please. So we talked a little bit about why we picked Kubernetes and containers, but the real additional aspects, of course, on top of the abstraction, so we don't get locked into a cloud provider or we don't get locked into a specific product. We also benefit from the fact that containers are immutable. We can centrally harden them and accredit them and use them as Lego blocks that can be swappable. But also Kubernetes as an orchestration stack brings resiliency, and so if container crash, they self-heal and all that kind of stuff, but also baked in security, and it's adaptable because of this Lego block concept, and everything is automated because we're using GitOps, which is everything is in Git, and we can push automatically that into staging and production. And then, of course, it's auto scales too. So based on compute and memory needs, you automatically adjust as needed, so you can save money in terms of cloud compute and storage as well. Next slide, please. So when you look at a DevSecOps stack, if you had to do all these pieces as containers, as virtual machines and not containers, you would end up having to update and patch all these VMs. It would be a lot of work. And if you have dev, test, staging, prod, and then you have different classification level, that becomes almost impossible to keep up with, and you have a ton of technical debt. By using containers, we are centrally accrediting these Lego blocks, and we can centrally update them with no downtime. We can push the containers every 4 hours across classification levels, so we have no drift between the classification levels. And we benefit from the cyber stack that can be injected as a sidecar container. So a sidecar container is a small container that runs alongside the bigger container, and it can inject cyber capabilities there that can do different things like behavior detection, a zero trust stack, continuous scanning and monitoring and alerting and centralizing logs and telemetry. So all of that is done by having a separate sidecar that can be updated regardless of the container. So we don't have to have any tight coupling between the container and the sidecar container. That's a massive win for the team, so they can release software at their own pace. They don't have to coordinate releases. So each microservice, each container can be released at its own pace. Very important as well. Next slide, please. So the layers are also foundational. We accredit layers, and then they can be swappable. The infrastructure layer could be a JAC, could be on-premise, could be a cloud, could be a FedRAMP cloud, could be a classified cloud. And then we're going to put Kubernetes on top. So we have different options. We have Rancher, we have D2IQ Convoy, we have OpenShift, we have VMware, and so on. And then on top of that, we're going to put the CI/CD pipeline with our hardened containers. Everything is containerized. And then on top of that, we're going to have the service mesh, which brings the zero trust enforcement using Istio for us, where we can do a mutual TLS tunnel and denial by default, and for container A to talk to B, it has to be whitelisted. And so by adding all these components as a sidecar container security stack, what's left at the application layer in terms of the NIST 853 controls with the last revision of Ron Ross version 5, you end up having very few of these controls left at the application layer. Hence, automating a lot of the cybersecurity framework controls with the bottom layers. And so what's inherited and the delta is very small. Next slide, please. So very important for teams that are trying to scale across a large organization. For us, Platform One is kind of that enterprise service that's providing capabilities to the rest of the different teams. That's also obviously very critical, and that's where we have the different science and technology teams like DARPA, AFRL, but also the defense industrial base and all the different large DoD programs using Platform One, but also now dozens of other federal agencies like the VA, IRS, like the DIC, and so on. So it's very exciting to see, and it's how we move faster, better, stronger together. Next slide, please. Just a map to show you how vast the DevSecOps teams are, covering pretty much every side of the DoD's mission. We'll go to the next slide. So when we build enterprise services, the key is not to have a one-size-fits-all, but have options. But at the same time, you don't want to have too many options, right? So it's a balance between not enough options, too many options, and you don't want to have shadow IT and teams creating their own things because your enterprise services are failing. That's usually a good hint if you see people building something multiple times that your enterprise teams are not building something that's good enough for them to use. And that's where we start to bring a bunch of options. Repo One is a source code repo where we have all the source code and infrastructure as code. All the containers are there on the source code side. And then Iron Bank, we have now 200 plus containers, and they are signed and accessible directly on that link that you see, ironbank.disa.io, and teams can go and consume these containers. Next slide, please. Then we partnered with a bunch of companies, Rancher, Day2IQ, Red Hat, VMware, Oracle, you name it. Anyone that does some type of Kubernetes distribution is working with us to bring their distribution directly into Repo One, already hardened and ready to go as a push button deployment, so team can just take it and run. It's already matching the DoD requirements, and anyone can go and consume those. Next slide, please. The main two services, and I think that's where it's so important to have both options. We have the Party Bus, which is the multi-tenant dev, test staging, and pod environment for DevSecOps. It's managed by Platform One. It's ready to go. Teams pay per use per developer per month to have access to the environments. They don't get to pick the tools. The tools are already there. We already pay the licenses, cloud storage costs, all the cost of cybersecurity, IT ops, everything is baked in. And then they just, use the stack to build software and focus on building their mission software. And then the Big Bang is a dedicated instance of Platform One that's great for larger teams that need to have specific tools so they can come and use that specific instantiation. And all that code of the Big Bang is also on the source code repo. So teams that are trying to rebuild a DevSecOps stack and bring Kubernetes and secure it, harden it, all that kind of stuff. Don't waste your time. Just go on the Big Bang repo and pull that automation code. It's using Terraform and code agnostic capabilities, so you can deploy it on your environment. But Platform also can do it for you and deploy it on your stack if you're a DoD team. And we do it DoD-wide, and we're the first DoD-wide approved DevSecOps team with DoD CIO. Next slide, please. Next slide. So training is key. We believe that's going to be the difference between teams that are just lagging behind or innovating. So we're bringing self-learning capabilities. You have the link here where we have some of our content there, but we also partner with a learning hub with O'Reilly, Linux Foundation, CNCF. And then we also do a 2-month onboarding where we do a minimal viable product where we can embed people from Platform One into the teams, and they get to just come and use it with us, and we build an MVP together as a team. So it's really more effective to do it as a team. Next slide. One more, please. For teams that need to also get into acquisition, we built DevSecOps contract vehicles, the basic ordering agreements. We have 3 contract vehicles for cloud services, for licenses, and for tenants. So we can award within 30 days and buy the things we need based on the demand of programs. So it's a great vehicle to move fast and be able to buy in bulk and get discounts and volumes as well. Next slide, please. Next slide. So that's something I want to cover quickly, and then we'll go back to Ron Ross. I want to make sure he has enough time for his slides as well. But the microservice architecture, when you move to having different programming languages per team, ability to release software in a decoupled fashion, you need a service mesh. You're not going to be able to be successful if you don't use a service mesh. The service mesh decouples a lot of the key components outside of the application, so you don't have to coordinate libraries and bits between programming languages across teams, like API management, service discovery, authentication, routing, load balancing, east and west traffic management, whitelisting, mutual TLS encryption, so all the encryption stuff. So really, the service mesh like Istio can do this for you at an automated decoupled layer, so you don't have to do this per team, per microservice, per programming language, and that enables you to update all of these things, by updating the service mesh without having to re-update the containers or the bits that you produce. So that really enables the decoupling. And I guess I'm going to pause here. I have more content, but I just want to make sure we give a little bit of time to Ron Ross and make sure he can cover his slides as well.
I am here. Can you hear me okay?
Yes, we can hear you.
Okay, Tracy, could you jump to that first slide, please? That was a great presentation, Nick. I still remember my first visit to the Pentagon when I was in your office, and you were listening to Nick's like drinking from a fire hose, but it's such an impressive body of work that he's built. And I think what I like most about it is, in today's world, we have to keep innovating. Innovation and speed are the key words, and I think that applies very much to cybersecurity as well. And we've been taking a close look at where we've come from in the last 20 or 30 years with all of our frameworks and our controls and all of the body of work that we've developed at NIST. And for the most part, the international community has also developed a body of work with international standards. But I think this DevSecOps to me has so many important things that I think will not just, it's going to revolutionize the way I think cybersecurity is looked at over the next several years. And right now, we're trying to look at all of the great concepts and principles that Nick described today in the DevSecOps, where we're looking at Agile, we're looking at all the pieces of DevOps and all the things that the industry is doing today to produce software at the speed of industry. And so I wanted to take a few minutes today to give you kind of a picture, a vision picture, if you will, on how all the things that Nick talked about can fit into a larger picture. And we've talked about potentially developing a DevSecOps framework. What would that look like? We don't really have all those pieces put together today, but I can give you some of the fundamentals that I think will go into such a framework. So if you can move to the next slide, Tracy, I appreciate that. What's the problem with today's systems? I think Nick has characterized it pretty well, and most of you in cybersecurity who've been doing this for years understand that our systems today are very brittle. We pretty much rely on a one-dimensional protection strategy that we call penetration resistance. We build up the moats and the barriers, we apply controls and safeguards, and we do it in the most complicated, complex environment we've ever seen in our history. The complexity of trillions of lines of code, billions of devices, and all of these coming together in 4 and now 5G connectivity, ubiquitous connectivity. The complexity is overwhelming. And so when you talk about protecting or defending, our strategy up to this point has been defending forward. We do most of our security work, unfortunately, at the end of the life cycle. And we've talked about this for years, of building security and baking it in. Those buzzwords have been around for a long time. I think the DevSecOps approach really gives us an opportunity to work closely with industry in a disciplined and structured lifecycle process to ensure that we get the appropriate safeguards integrated into those products, systems, and services well before they get to the customer. And so if you could go to the next slide, Tracy, I'll try to amplify a little bit on some of these concepts. I think the other thing I think you're hearing from all the speakers today, or most of the speakers, is this understanding of we don't understand what's in the black box. I use that as a metaphor to talk about things like smartphones or tablets or supercomputers, anything where there's a computer and you have the complexity of the system stack. And Nick alluded to some of these things in his talk a few minutes ago. Stack has applications, middleware, operating systems, firmware, integrated circuits, and going out to the network, all that connectivity. But we really don't understand what's going on inside the black box. And we try to do assessments and we try to get as much information as we can. But the reality is these complex systems are not giving us the information we need to make credible risk-based decisions. And that could apply also to the supply chain components that you heard about in the last presentation. It applies to almost everything that we deal with in this very complicated world. So we definitely need to have more transparency and traceability, visibility into how these products, systems, and services are built, how they move through that life cycle, all the way till they come to the consumer. And that trust and that assurance is essential, especially when we're using these great new innovative technologies in some of our most mission-critical systems. And I think that you saw with Nick's presentation, I've been kind of following, they are putting the DevSecOps work in some of the most critical DoD systems. And so what I like about this is it's really a use case that works at scale. And it's not just for toy systems. These are systems that are, in essence, defending the country. And so I think this is worth a lot of investigation and a lot of looking at how we can bring these concepts together in a framework that can describe this process so we can understand it, and it can be applied to scale across the public and private sector. Next slide, please. We talk a lot about security vulnerabilities, and the complexity I've referred to, it is a real problem, because if we don't understand what's in the black box, we don't understand the process of how these products come off the line, we will always be defending forward, trying to do things at the end of the life cycle, which really can affect the fundamentals of that product. Secure coding techniques and all the things that good software that we can trust and we can rely on. But when we talk about vulnerabilities, there's really 3 different areas where things can go wrong. And I just highlight these because they really do talk to DevSecOps. If you don't have a good set of security requirements going in, and this would apply to any type of lifecycle process, whether it's Agile or Spiral, whatever it is, you have to roll with an initial set of good requirements. And so when you have those requirements and you build those components and those features in accordance with those requirements, tend to go well, but sometimes we miss requirements. We don't go through an appropriate requirements engineering process, which is really the front part of that system development lifecycle. The next area we can run into problems is you can have a great set of requirements, but you mess up the development. One of the things I like about the DevSecOps approach that Nick described today is that there's a very disciplined and structured way he's producing that software. The containers, the inheritance of security capabilities, from the bottom up to the top of the stack. All of that is good, sound software engineering techniques. And really, most of our problems today, if we could solve the software engineering part of these problems, a lot of the other problems will go away as well. So good requirements, a good development process, and that means having a trusted development environment and having competent people, as Nick described, going through this massive training process where you have to be able to train people to understand how to do the right things in the DevSecOps process. And then the last area that things can go wrong, even if you have great process, when it comes to operations, things sometimes can go awry. We used to call that operator headspace in the Army, but you have to be able to implement those product systems and services correctly and make sure that all of those things come together in the operational environment. This is when you're out there in the combat zone, for example, you're in the desert with the dust and all the stuff that, you know, the things that go on in real world operations. So these concepts have to be sound, they have to work across the board, and they have to be scalable and operate in real world situations. Next slide, please. Some of the DevSecOps fundamentals that I've been picking out as I look at what Nick's been doing, and I've also talked with other industry partners who are working on DevSecOps and Agile development, is that there's some things that jump out. And I think these are the kinds of things that you would expect to eventually emerge in a framework. And again, a framework is not to ensure that everybody's using the exact same product. It can establish a common dialogue so we understand what DevSecOps is, what its fundamental concepts are, and how we can use those to both serve producers and consumers of this technology that we all use so extensively today. But the first point is the integration of security early and throughout the life cycle. That's something, again, that we've worked very hard on with our 800-160 series, our security engineering series, looking at the ISO 15288 standard. That's the system and software lifecycle development, and to integrate all 30 processes with security measures, concepts into those 30 lifecycle processes. That's true security integration throughout the lifecycle. We must have a disciplined and structured software and system development process, as Nick described, and that security inheritance is one of those nice side effects that come with that disciplined structured process that describe the inheritance coming from the bottom of the stack all the way up to the application level. And then, of course, we have to be able to work at the speed of industry. We can't go back to the days when everything gets slowed down because of security. Security has to move with the development process. We have to take advantage of the innovation, and we have to be able to move in that direction, because that's where we're actually going to win the cyber war, by being faster, by being more nimble, and having all of these things built in deep into the system, and be able to spot those things out quickly, as Nick described in his presentation. We talked about trusted development environments, trusting the process and the people. That's something else. When you talk about continuous ATOs and you talk about where do we actually spend most of our time on the ATO process, it's way too late in the system. We have to be able to move some of that assessment and those authorization type activities further back in the life cycle, so we don't have to have that black box phenomenon that we have today, where you get these products and systems and services and you don't really understand what's going on inside. Trusting the process, making sure that they're following these conventional concepts that are being described today, and they're doing it well. That's where quality really resides, in the life cycle. And then continuous integration, again, industry is going to keep on innovating, keep on moving. And I think what Nick described is a process to keep taking advantage of that innovation and doing it in near real time with good security. And that continuous integration and delivery, the process, that's critical to making sure that these systems have a life cycle, they can go on and on and on, and not have to be get into the same legacy situation that we have today, where we have lots of code. It's old, we don't know what's going on, and that's not really serving us very well, either functionally or from a security perspective. And then finally, continuous monitoring and the ATO process. That's really where the action is in the future. We have to be able to understand that security is not a static process, it's dynamic. Our threats are changing, the technology is changing, the missions are changing constantly, especially in organizations like the DoD or DHS. So this is the way that some of the fundamentals that I think would be captured in the DevSecOps framework. Again, it's not to limit innovation or limit people to certain processes, it's to define fundamental concepts that we all agree can be beneficial to giving us better security that can operate at the speed of industry. And I think that's the real benefit of what I see in Nick's work, and others out there too. Nick's not the only one, but he's got the most visible project right now. Next slide. This one just kind of brings everything together. I think you've seen the DevOps slide. DevSecOps is nothing more than really bringing some of those fundamentals on my previous slide I described. Agile development is the core, security architectures, the application security, the measurement, the review, the code, the testing, all of that, especially secure configuration, making sure that code is locked down and is under strict configuration control. And again, the thing I didn't mention is DevSecOps right now in Agile development is pretty much applied at the component level. One of the things we'd like to explore with Nick and others is how do we explore the DevSecOps process when we're talking about a system where you've got these different modules coming together, but we still have that nagging issue of composability. And I think we can take a lot of what Nick has been exploring and other industry partners, and we can define that framework so we can apply DevSecOps to the component products like he described today, but we can also describe those at a larger systems issue when we're dealing with aircraft or automobiles, where you're bringing in lots of different software components and hardware components and firmware into this big thing we call a system. And there is where the 800-160 in the lifecycle process, we have really well-defined structures there. But we have to look at that in the context of DevSecOps. Which of the traditional processes might have to go by the wayside? We have to keep an open mind and really be thinking like innovators and try to get the next generation of how we're going to protect these systems, not defending forward, but defending from early in the life cycle. Next slide. Just my last two slides here, I wanted to kind of bring this back together because I've talked a lot in past years about the 800-160 and how I believe that we have relied on that single dimension strategy of protecting our systems called harden the target, penetration resistance. And I think we've seen over the literally 3 or 4 or 5 years now these continuing cyber attacks where even if we're doing the right thing with every control on the planet and all the good development techniques, we still have adversaries that can find that weak spot. In the complexity of the systems we're building today, there will always be an opportunity in that complexity to find those weaknesses or deficiencies. And if they can be exploited, those are continuing vulnerabilities. So what do we do? And this is really the purpose of this whole summit every year, is to talk about cyber resiliency and resilient systems. And I think that describes in this chart here, this graphic shows that we do need a multidimensional protection strategy. We can still try to harden the target, do all the things that we've done before. We can do all the things in the DevSecOps world, but we still have to understand what it means to limit the damage once that adversary has breached our perimeter or they've attacked the system. They've done something to affect our capability. And damage limitation, again, some of the things in the DevSecOps world are going to actually allow us to do damage limitation and make the target, that system, highly resilient. I'm going to go to my last slide now just to give you a couple of examples of how we can limit damage. And I've actually used these before, but I think they're really appropriate today. If you want to go to the second and the third dimension of damage limitation and true cyber resiliency, you have to be able to affect the adversary's ability to either stop the adversary from getting in, but if they do get in, what can we do to reduce their ability to cause damage? And we can do that in 2 ways. Nick talked about, I'm going to jump to my second point first. He talked about zero trust concepts, zero trust architectures. That's kind of built in to the DevSecOps works that you heard in Nick's part of the presentation. Domain separation, network segmentation, micro segmentation. In essence, when you use zero trust concepts, you make it very difficult for the adversary to move laterally throughout your system or even jump from system to system. You increase their work factor. And in fact, you increase it so much that they may give up and just go away. The other thing we can do is limit the damage in time. Adversaries have to go through an attack sequence. The thing they absolutely have to have is time on target. They have to understand the environment. And when you're doing some of the things like virtualization, micro-virtualization, you're churning the infrastructure faster than the adversary can actually take advantage and exploit. So in some sense, if we can do the things that Nick's talking about today in DevSecOps, and if we can do damage limitation and cyber resiliency, it won't make any difference what the adversary does because we're moving faster, we're changing the environment, and we have assurance in those components that we're building into these systems that are going into our most critical systems. it's an exciting time. I'm really excited to be moving from the FISMA work into more of the engineering work and the DevSecOps work in 2021. And I'm looking forward to partnering not only with Nick, but also with all of the great partners out there in industry. And we have some really great things on the horizon we can do together. And I think I'm going to stop there and maybe take some questions if we have time.
Okay, yes, we do have some time. Let me go to the questions. There's one here from Kimberly Underwood, and this is for Nick. It says, regarding the DevSecOps architecture reportedly planned for initial release in December, that you at DoD and DISA are creating, how will you scale its use across DoD? And how are you preparing to leverage the cloud and the architecture?
Yeah, so the reference design architecture was released back last year, August 2019. We're going to do a new update in the next couple of months now. And we are going to make it also a living document so we can update it as fast as needed. In terms of its use, I think we have a lot of different programs moving to DevSecOps. We have some of the largest DoD weapons moving to DevSecOps. In fact, the Air Force is working on really having some mandate by which most of the non-COTS SaaS programs would end up moving to DevSecOps. So any program building software really would have to move to DevSecOps within a couple of years for non-real-time systems and 5 years for real-time systems. So we're trying to put a little bit of pressure as far as when that's going to happen. So I think it's going to be a pretty broad spectrum, and by definition, the default will be on the Cloud One cloud. So Amazon Azure classification level, where we want to go, and that's where we want to be. So that's kind of the big push we're doing now.
Okay. Here's a question. What changes are happening in the ATO process to assess containers during the DevSecOps processes such that they are really doing continuous ATO? Well, this doesn't move well. They are really doing continuous ATO at the speed of development.
Well, the ATO process is almost completely different. One is we're not accrediting one piece of software. We accredited the factory and the gates within the factory and the change management gates, the testing gates, the Cyber gates, the how many set of code we have to approve code change and things like that. By passing those gates, whether it's a container or not, but if it's a container coming out of the pipeline, we have a container hardening guide, which has steps in terms of the hardening we have to do to approve a container for DoD. We just released the container hardening guide as well. So that helps, define the gates, the left and right gates by which, the development team has to follow to be able to get a container approved DoD-wide, and what comes out of that pipeline is accredited. And of course, the containers that are within the Iron Bank are already DoD-wide approved, so they can be reused. And we have a lot of agencies trying to use them as well outside of DoD. So we're kind of becoming the central secure Docker containers registry for the government.
Okay. Here's a question from Rick Goodwin. Is NIST doing anything to help identify what needs to be assessed at the container level for ATO assessment? And has the USAF, the Air Force DevSecOps, done anything to automate generation of information about the containers and the development and release of containers to support automation of the ATO process? I'll go to Ron first on NIST.
Couple of questions there. I think the first question is what are we doing to help the assessment process? As Nick talked about, one of the things that he does in all of his work is he's looking at security controls and security requirements throughout that process. And so one of the things I would like to try to do, our risk management framework, the NIST 837 Rev 2, right now the authorization process, as Nick said, focuses on authorizing systems and common control. That's about the extent of what we described. but I would really like to explore some of the ideas that Nick talked about. When you're going through a DevSecOps process, or even a general lifecycle process, there are lots of opportunities, lots of assessments occur. Testing and evaluation is always going on during the lifecycle. And if we know that's a sound, structured process and producing assessment evidence throughout the lifecycle, I believe there's a way that should be able to be captured and sent forward to the authorizing officials. Now, it may turn out that those assessments are using some of the same assessment procedures that we define in 853 alpha, or maybe they're using testing evaluation techniques and procedures that they define as part of their own life cycle. It really doesn't make a lot of difference, except that we need the evidence to be brought forward so we can understand the level of trust we can have in that particular product or component as it makes its way through eventually to that final ATO decision that's going to look at the entire system, all the components that are working together to give that organization a capability. So we're looking very closely at how that's going on right now, and then trying to see if we can capture, define that process so we could update our publication to reflect that potential capability, and then customers would be free to use that or depend on that evidence as it comes through the development lifecycle.
Okay, we're near the end of the session. Do either of you have any final thoughts you'd like to offer? Nick or
You want to
Ron?
go first, Ron?
Well,
I can go first if you want.
I think
You go.
the whole conference today talking about cyber resiliency, and I think what we're seeing with Nick's work and others that have talked on panels today, there really is an incredible opportunity to build on the solid foundation of cybersecurity and privacy now that we've built over the last 40 years. Cybersecurity was never to be static or a one and done. It's about evolution and revolution in some cases. Sometimes there are big things that happen we didn't even expect. And I think we have to take a serious look at that and make sure that we can take advantage of all of those new things that we're seeing, especially in the context of a highly innovative and just the technology lifecycle we're seeing today. So I'm excited about the future, and I'm really glad to be able to participate today. Nick, over to you.
Yeah, thanks. I guess for me, it's all about collaboration. So I really want to insist again on the software.dev.me website. We have the source code repo there. It's a two-way street. You can share your containers with us. You can provide feedback to improve the existing hardening of the containers. We really want to learn faster together and be stronger together. So really welcome the opportunity to share and have that conversation. We do Ask Me Anything events every 3 weeks. So the next one is next week on Thursday at 1 p.m. Eastern time, where we can answer all your questions live. We do about 80 questions every Ask Me Anything sessions for 2 hours. So that is also under the event section of the software.dev.me website. Thanks for having us today.
Nick, Ron, thank you for a great session on the critical nature of adding security into a DevOps pipeline and the work that's done in producing the products that go through that pipeline.